Welcome to EDU World Space.
Here we have a football that is being kicked into the goalpost that is 36 feet away horizontally, and the goalpost is 10 feet high. So what we want to do is first find the minimum angle that the ball can be kicked to be hit over. So first what we're going to do is change these feet to SI units. So I'm just going to give you what they are. You can convert it yourself. That's 10.9728 meters. This is going to be 3.048 meters. All right, so what we have to do is find the minimum angle that will be kicked, and if it's anywhere below that angle, no matter how fast you kick it, it won't get over the goalpost. So what we're going to do is we're going to draw these two lines. Here's a horizontal of 10.9728 and 3.048. And so no matter how hard you kick it, if you kick it as hard as possible, the least amount of distance it will take will be this diagonal line. So what we want to do is find this angle right here. And that's just going to be given by tangent. So tangent of theta is equal to 3.048 over 10.9728. And using the inverse tangent, we get that theta is equal to 15.5 degrees. So now I'm just going to draw the picture again. It's going to start from here. It's going to go here. And then we know this distance is 3.048. The horizontal distance of 10.9728. So now we're given that it is being kicked at an angle of 45 degrees above the horizontal, which means this angle right here, 45, or we're going to call it theta. Theta equals 45.0 degrees. And what we need to find out is the initial velocity to get it just over the goalpost, which is this height. So first we're going to label our variables. We're going to call this Vx, and this one's going to be V naught y. We're calling this V naught y because there is acceleration in the y direction, and there is no acceleration in the Vx direction. And so one inference we can make right off the bat is since theta is 45, we know that V naught y and Vx must be equal to each other in order for this angle to be 45. So what we're going to do is going to use our kinematic equation. So we have delta y is equal to v naught y t plus 1/2 acceleration times time squared. So acceleration is going to be due to gravity, so acceleration is going to be 9.8 meters per second squared. But since it's downward, we're going to do negative. And we know delta y, which is going to be this 3.048, because that's the vertical distance. So what we need to do is find this time. So we're going to use our Vx is equal to delta x over delta t, where this delta t and that t are going to be the same thing. So Vx is equal to, then our horizontal distance is 10.9728 over t. I'm just going to call it t. And rearranging, we have rearranging, and then we can substitute v naught y in for Vx. So we actually have t is equal to 10.9728 over v naught y. And now we can plug t into that equation. So we have 3.048 is equal to v naught y times t, which is 10.9728 over v naught y, and then minus 9.8 times 1/2 is 4.9, so 4.9 times 10.9728 over v naught y, and then this quantity is going to be squared. So we see that this cancels out, and I'll let you do the math, but v naught y is then going to come out to 8.628. Now if we draw a triangle again, we know this angle is 45, and we know that v naught y is 8.62, and we're looking for initial velocity right here. So all we're going to do is use one of our trig functions. So sine, we're going to use sine of theta, which is 45, is going to be equal to opposite, which is 8.628 over I hypotenuse, which is v naught. And then solving for v naught, we get v naught is equal to 12.2 meters per second. Now, if we want to change that into kilometers per hour, we're just going to take 12.2 meters per second. We're going to cancel the units. So in 1 kilometer, there is 1,000 meters. And then you multiply it in 1 hour, there is 3,600 seconds. And that's going to come out to 43.9 kilometers per hour.